Here's one fact that you probably didn't know about yourself. Your body contains enough carbon atoms to build over 5 billion copies of the entire Milky Way galaxy. Mass. And yet, despite being this incredibly complex system, our universe can be explained by just two theories. Everything from the very small to the very large is governed by the laws of quantum mechanics and Einstein's general relativity. That's pretty incredible when you think about it. However, despite these theories being so successful, they leave a lot of questions unanswered. So in today's video, we're going to take a journey through the cosmos and look at some of the most exciting areas of physics that are attempting to fill in the gaps between these two great pillars of knowledge. This is a special mini-series called From Quantum to Cosmos, where I will discuss some of the biggest open questions in physics today. So let's get started with the first question that we all have. Ever since we looked up into the night sky and wondered, why is everything always moving? Why does the apple fall to the ground instead of flying off into space? Why do planets orbit stars instead of just drifting apart? Why don't galaxies collapse? It's not enough to say that the answer is gravity. There has to be something more to this. We want to know what makes gravity work and how does it compare with the other forces of nature. Now, before I go any further, I should mention that there is an award given annually for the best theory of gravity. It's named after the late John Archibald Wheeler, who once described gravity as the seat of mass. He also coined the term gravity for the hypothetical force that brings the universe back together at the end of time. Now, his prediction actually came true last year when scientists found evidence of a previously unknown type of fast radio burst that seems to have originated from almost every galaxy in the observable universe. They've been nicknamed fast radio quiets, or FRQs, because the signal seems to turn off as quickly as it turns on, but no one is sure exactly what they are. Some scientists believe they could be the result of collapsing neutron stars known as a kilonova, which is thought to be responsible for creating heavy elements such as gold and platinum. Others speculate that they might be coming from extra-dimensional beings trying to contact us. However, those people are not serious. Okay, but getting back on track, despite this recent development, we still don't have a complete understanding of gravity. In fact, we know that Einstein's theory of general relativity breaks down under certain circumstances, like when matter is compressed into an incredibly small space, or when light travels near a black hole. One promising approach is to think of gravity not as a force, but as a manifestation of the curvature of space-time caused by the presence of mass and energy. If this is true, then we should be able to develop a theory of gravity from general relativity that describes how empty space has a structure to it and how matter moves within that structure. But to do this, we would need a new theory to replace general relativity, because the mathematics used in general relativity cannot describe empty space. One such theory is loop quantum gravity, which quantizes or discretizes space itself. In this theory, space is made up of tiny loops called spin networks, which are connected together at points. These points represent where matter can be found. The theory predicts that, at the smallest scales, space should look like a tangled mess, which explains why quantum particles behave so erratically. As you move around in space, you drag your tangled webs with you, and they become more and more jumbled, until you reach a critical point where they snap back into place and release a burst of energy. This process is similar to what happens when a supercooled liquid like honey suddenly becomes unstuck and flows. But instead of a liquid, it's space itself. This is a really cool idea. The problem is that loop quantum gravity doesn't agree with observations of the cosmic microwave background. There are also other issues with the theory, such as the lack of a time variable and problems with black holes. So while it's an intriguing idea, it's far from a complete theory. Another theory is causal set theory, which is based on the idea that events in spacetime are fundamental, and that the structure of spacetime emerges from the relationships between these events. Events are points in spacetime, and they have properties like location, time, and whether or not something happened there. For example, if you were watching this video, then you were in a specific location, in a specific time, in a specific spacetime event. Causal sets are mathematical structures that encode these relationships. Each point in a causal set is connected to other points by arrows that indicate the direction of time. This creates a network of events that can be used to reconstruct spacetime. In fact, scientists recently used a machine learning algorithm to reconstruct the gravitational field of a black hole from a causal set. The algorithm took the data from the Event Horizon Telescope, which is a global network of radio telescopes that captured the first image of a black hole in 2017. The algorithm then used this data to generate a causal set that represents the gravitational field around the black hole. The results were published in the journal Physical Review Letters, and it shows that machine learning can be used to study the properties of black holes without having to solve Einstein's equations. Pretty cool, right? But there are still many challenges to overcome before we can use causal sets to describe the entire universe. Alright, now let's move on to the next big question. If we can't even explain how gravity works, then how can we explain how the universe began? How did all the matter and energy get here? Well, we do have a theory for that. It's called the Big Bang Theory. And according to this theory, the universe began as a hot, dense singularity and expanded outward. And this expansion continues to this day. However, the Big Bang Theory doesn't explain what caused the Big Bang in the first place. It also has some problems like the horizon problem and the flatness problem. To understand those, let me introduce you to the concept of the particle horizon. Imagine you're standing on a beach and you see a wave approaching you. Can't see beyond the wave crest, and there's a limit to how far you can see. This is called the particle horizon. Now imagine you're standing on a beach again, but this time there are two waves approaching you. Again, you can only see one wave at a time, but you can see both waves if you move to another spot on the beach. This is the same thing that happens in the universe, except instead of waves, it's light. Because light takes time to travel, there is a limit to how far we can see into space. This distance is called the particle horizon, and it tells us how far light has had time to travel since the Big Bang. The problem is that the particle horizon tells us that the universe should be filled with a sort of fog, created by all the light that's scattered off of the particles within it, but we don't see any fog. Instead, the universe is completely transparent. This is known as the horizon problem. How did the universe become so smooth and uniform when it should have been filled with a fog? Another problem is the flatness problem, which says that the universe should have collapsed long ago, if it weren't for some kind of unknown force keeping it expanding. So what's going on here? One possible solution is inflation. Inflation is a theory that says the universe went through a period of exponential expansion in the first few seconds after the Big Bang. During inflation, the universe expanded by a factor of at least 1,000,000 trillion, which would have smoothed out any initial irregularities and solved the horizon problem. It would also explain why the universe is so flat, because any curvature in space would have been stretched out during inflation. But that's not the only theory out there. Another possibility is that the universe is actually infinite. This may sound weird because we can only observe a finite amount of space, but that doesn't mean the universe is not infinite. It just means we haven't discovered any other parts of the universe yet. If the universe is infinite, then it should have always existed and always will exist, so there was never a beginning or an end. This is known as the eternal inflation model. But wait, if the universe is infinite, then shouldn't everything be infinitely large? No, not necessarily. In fact, eternal inflation would actually explain why the universe has a finite size. That's because the parts of the universe that are not being inflated would eventually collapse due to gravity. So the only parts of the universe that would continue to expand are the ones that are being inflated. This is known as the eternal heat-death model. If that sounds confusing, it's because it is. So let me break it down for you. According to the eternal heat-death model, the universe will never have a heat death, because there will always be some part of the universe that is being inflated. However, the parts of the universe that are not being inflated will eventually reach a heat death. What will happen to those parts is they will collapse and begin to re-expand. And this cycle will repeat over and over again for eternity. Either while the universe as a whole will never die, parts of the universe will keep dying and being reborn. This is a pretty bleak outlook for the future of our universe. Now, I should mention that I am no expert in cosmology, so I may have oversimplified some things here, but hopefully you got the general idea. If not, then please leave a comment below, and I'll try my best to answer any questions you have. Also, make sure to check out my other content if you want to learn more about the amazing discoveries made by scientists around the world. Thanks for watching, and see you next time.